So, good morning, everyone, or good afternoon, depending on where you live. My name is Debbie Madden. I'm the founder and chair of Stride. We're really excited to have you here with us today for the next hour. A quick intro about Stride for those that don't know us. We are an agile software development consultancy. Our specialty is helping you get high quality custom software to market while at the same time upskilling your team. And over the past several months, that has a lot to do with generative AI, and that's what we're here to focus on today. So I'm really excited about today's webinar. We're going to be diving into what's possible beyond Copilot, and then we're going to take a bunch of questions and talk about our predictions about how software development is changing and excuse me, how we think that this is going to change in the near future in the coming months. And so we're here to help you, right? There's a lot of Gen AI noise out there, and our hope is to help you cut through that noise so that you can focus on what's important for your team and your goals. And that, like I said, we will have time for Q&A, both at the end, but also throughout. So don't be shy. Feel free to use those that chat, and I will call out the questions, and we'll get to them, either during the session or at the end as time permits. And at the end, we're going to be giving you a special offer, so be sure to stay to the end. We're also going to be sharing the recording with you in case you miss anything, so you don't have to take detailed notes. You can sit back and enjoy. And with that, I'd like to hand it off to the folks that are going to be teaching you today, Michael Carlson and Dan Mason. Take it away, guys.
Awesome. Thanks so much, Debbie. Super excited to chat about this today. We've been doing a lot of work, and we're excited to share what we've learned and how we see all this panning out in the future. My name is Michael Carlson. I'm a partner at Stride, and leading up the charge for what we're dubbing Stride Labs, which is our sort of Gen AI offering. We're working on all these new next level solutions. Joined by Dan Mason, who's our AI practice lead and our principal on our team. So to set just expectations for the session today, we're going to quickly do an introduction. We'll chat about ourselves for just a second to give you a little bit of context. And then we'll go in and we'll talk about the status quo of Gen AI and Gen AI and assisted development. Then we're going to go beyond Copilot, which is sort of the status quo. We're going to talk about where things are going next, implications for the future, and then we're really excited about the Q&A part. We've been talking to a lot of customers about these ideas, these solutions, what we've learned, and the conversation is just wonderful. So we're going to hopefully have a nice, thorough amount of time for that. All right, so this is quickly us. We are, as Debbie said, we develop custom software frequently with people you've heard of. Some of those are you. Welcome, friends, current, former clients. We exist to help our clients deliver value for their customers, and we care about their outcomes, and we also care about the craft and collaboration and the human side of developing software together as teams of humans. And that's why this is all so compelling for us today. Later you'll see a little bit more about our what I call our thought doership, sort of putting our ideas into action. But we're also doing some thought leadership as well. We have an LLM crash course. We have a blog. But what I really want to kind of call out just quickly here is Dan, who you'll be hearing from in a couple minutes, posts every week to LinkedIn one thing that you need to know about Gen AI this week. It really helps cut through the clutter. It's a great read. He'll link out to some interesting piece and our sort of unique taste on it. So definite plug for that. One of our other elements or our other forms of thought leadership has been doing these webinars. And last time we made a prediction that agents are going to be the next big thing. And not to bury the lead, but that's what we're going to be talking about later today. So agents in and of themselves are these super interesting concepts that we're going to dive into. They basically are ways for us to do tedious work or to parallelize all sorts of work streams, ways to get more work done faster. And we'll see how that is connected to the software development lifecycle in a couple minutes. First, we want to talk about the status quo. The status quo is Copilot or different Copilot functions. Let's just talk a little bit about how that works so you can see kind of how people are using generative AI right now, and then see how that's going to evolve into the future. So traditionally in software development, we've got a product manager, a designer, a couple developers. They're working on requirements together. The product manager and a group of developers refines those requirements. The developers go off and spend hours or days or potentially even weeks developing the things that were agreed upon. And that cycle time is a couple of weeks so they keep kind of iterating on that until it's done. With Copilot, there's some assistance from generative AI that's helping to expedite that process and help that developer pair as a new sort of teammate. See what that looks like in the next slide. Copilot is basically an autocomplete sort of on steroids. It's able to autocomplete functions. It's able to write tests. It's able to generate things like basic APIs, sort of traditional development tasks, but it's all very, very local. Jump to the next one. What's great about it is it's a little bit faster. It helps developers kind of keep in flow, right? So they don't have to worry about typing some long block. Sometimes that'll be auto-completed for them. There's some modest speed and efficiency gains, a few percentages points here and there in terms of how long it takes to get something done. And it was sort of easy to fit into your flow, right? As a team, you add Copilot in and it's kind of seamless, right? And you get those gains pretty easily. But there are some weaknesses as well. Those gains are only marginal. They aren't sort of groundbreaking. Marginal gains are important, but it's not a step change. It scales linearly, so each developer on the team could be a pilot along with the Copilot. So you can only have one Copilot per developer on the team. Scales linearly. And it doesn't do anything to really improve interdisciplinary team collaboration, cycle time, cadence, that sort of thing, right? So it really is just localized to one specific developer. And we're here to show you that there is another way. There's an evolution beyond this. And I'm going to turn it over to Dan Mason, who is going to show you that way.
Thank you, Michael. So I'm excited to talk to you guys about how to use this concept of agents in a development context. I think that's really what we're all here to talk about. But I do want to start with a little bit of background on agents, because this is a very buzzy thing that I think has been also kind of poorly defined, right? There's a lot of different people out there talking about, my solution uses AI agents, and some do, and some really are just kind of thin wrappers around, the ChatGPT that we know and love. So I wanted to start here by making, a kind of a crisper definition of this. So an agent in, the AI context is doing something, right? It's not just limited to the scope of the chat box. It's executing a task. I think it's important also that task affects some kind of environment that you care about. Could be digital, could be physical. We'll show some examples of doing this in the context of code repos, right? That is, an agent executing tasks which affect an environment like a code repo. And often, but not always, these things can be across systems, right? I think that's a lot of the stuff that's gotten people the most excited are when you're talking to ChatGPT and it's doing something for you either in the digital or the real world. So one example is over here on the left, a reservation agent, right? Make me a reservation at this restaurant, right? So in this case, the agent is doing part of the job, right? The ChatGPT agent. It's finding the reservation, still making you book it, right? So this is kind of an imperfect, but indicative implementation. Copilot also has some of these agents. And so one example is you can ask a Copilot agent, in this case, the @workspace agent, to answer a question based on your code environment, right? So that's, again, it's a very thin, layer, but it's saying, instead of you having to go and read all this code yourself, I will go read the code for you and try to answer your question, in the context of our chat. And another good example would be things like, a customer service bot on an e-commerce website where you can ask for order status, cancel my order, make a new order. That isn't necessarily an LLM task, right? Those kinds of agents exist in the real world today. But this is what we're talking about in terms of AI agents. The thing that we think is particularly interesting is what can happen if you create teams of agents. And there's a couple reasons for this, right? So one is that we as technologists have most likely all tried to use LLMs to write code. And when we do it, we're speaking in plain English to a single other personality, which is doing something under the hood and returning back both a plain English answer and code. But the thing that you don't necessarily get is true insight into the thought process. You don't necessarily get the ability to have the agents break down, essentially a task. You have to do the breakdown. You have to say, here's what I want you to do, and then maybe walk step by step through getting out the outcomes that you want. And again, in large part, when you do that, you're doing it in the context only of the chat window. You've got to do a ton of copy and paste or integration back with your repos. And so what we think you can do by putting agents, and again, defined as things that can execute tasks and affect your environment, if you put them together in concert, you end up with something that looks a lot like a dev team, right? And we think that's one of the key insights here. It's not that you couldn't just ask ChatGPT to build you a bunch of code and that code very well might work, but this actually gives you some inspectability. You can see what the agents are doing. You can observe the process. It is clearly more effective, and this is through empirical evidence that we've seen at decomposing larger tasks and harder problems, right? It also is possible for the agents to critique each other and improve each other's results. There's a bunch of interesting scholarship out there. I encourage you guys to check it out. There's an agent framework that we've used called Microsoft AutoGen. That's the one that a lot of these demos that we're going to show you are built on. And there's a lot of good evidence starting to emerge that this approach is not just cute, but actually works better, right? And there's reasons to use it, especially in contexts like this, where there are very well understood processes. Building software is something that I think we all understand, at some level and have a lot of process for. We're trying to bring that process forward to leverage these AI agents. So now what I'd like to do is do a fairly high wire live demo for everybody. So let's all keep our fingers crossed. But the thing that we really want to show you here is that we've got a basic application. So this is a React app, which I'll show you the code for in a second. And I've built a very, very basic to-do app here. And you'll see how basic in just a second. So I can type in to-do items, and I can put as many of them as I want. And I can see, great, now I have a to-do list. This to-do list is not particularly full-featured. So let's say that I, as a product manager or a developer, am interested in extending the functionality here. So maybe I want to add a delete button. Maybe I want to add to-do dates on each of these items. And so I've got the code. I'm going to jump over to VS Code here. I've got the code loaded up. And what I have here is a Python script. And I'm going to walk you through this Python script. This will take just a second, but I think it's important for you guys to understand what's happening here. So at a high level, what I'm doing is I'm defining a set of agents who are going to work together to solve human sort of coding problems. And the first one I've got here is the coder. So the coder in this case is fundamentally the one who is going to create the actual code, but also create the mechanism for putting that code in the appropriate place, right, in the repository. So I've got, as a software developer, I'm responsible for updating a code base, right? We are telling it that there is context that it needs to have and it needs to work with. You're going to write code, you're going to overwrite files in the repo, you're going to be able to troubleshoot and debug and optimize these code with help from the other agents. And we're actually asking it in this case, and this is a very, very simple example, and we've actually got a bunch of more interesting ones for larger code bases. It's going to respond in a shell script that's just going to make edits to these files, right? Very, very straightforward. And in this case, this coder agent is one personality. I've also got a concept here of a code base context agent, right? Where effectively we're putting the code into, one term you may have heard in LLM land is RAG, retrieval augmented generation. We're essentially taking the code base from its repo, vectorizing it, storing it so that LLMs can have access to it, and then you can have that context provided essentially to these agents, right? In this case, we've hard-coded everything here, but you can imagine provide any code base you want, right? I've got a to-do app here. I provide the source files, and this agent is now going to be able to work with the other agents to provide that context. And then I've got an agent down here called a debugger. So the debugger agent is going to look at essentially the state of things, right? The code that's been provided, the execution that we're going to do in just a second, and then actually provide feedback essentially back to the other agents about any errors that may occur. Now, if there are no errors, the debugger doesn't really have a role, right? So the debugger is an optional sort of silent agent in cases where everything goes well. Now, we've got a bunch of other agents here that I've commented out, different configurations. You can imagine all of this as a prompt engineering challenge, right? Figuring out how to provide the appropriate context into this team of agents. And then down here, I've got my final agent, which is the executor. You're going to run the shell scripts that update the code and then run the code itself. And then what I do, and this is a key element for AutoGen, is you put them all in a group chat. And we'll be able to see some of these examples in a second. I put the 4 agents that I've defined in a group chat. I basically create a group chat manager, which is going to silently route messages between them. That's another AutoGen feature. And then I'm going to ask it to do something. And so here, the user story that I've defined is one of the first ones that I mentioned. Update the application to have the ability to delete to-do items. I want it to create tests. I don't want it to actually run anything. This is partly just not to confuse it with my environment. It's a React app. It's going to automatically reload. But in this case, I'm not giving it any context on the code other than the code itself. I'm not telling it what to do, like where to put, the specific, behavior that I want. I'm not telling it sort of what the to-do items are. I'm asking it to actually read the code and figure that out. And so what I'm going to do here is I'm going to run this Python script. These things tend to take anywhere between 5 and 30 seconds to run. It really depends. So I'm going to let this sit here and run. I am going to go and find my resize button over here. And you can see here the script finished. My code reran. And if I go back to this application, I've now got a delete button. And as you can see here, it actually works. So in this case, again, I ran this script with the requirement that I had. It took input code, modified it, saved that code off. And now I've got a live example of the new feature that I wanted. And I just want to take a second. I want to prove to you guys that I can also do that again, right? I can iterate on this process. So I'm going to comment out my little snippet here, and I'm going to go to my second task, which is I want you to update the application to add due dates, right? And adding due dates, again, I'm not giving it a lot of details here. I'm still asking it to figure out the to-do item. And I just wanted to add a due date. So I'm going to go back and I'm going to run the same script again. And again, depending on exactly how long it takes, this is doing a round trip, in this case, to OpenAI, right? So I'm passing code to OpenAI. I am allowing the agents to have essentially a group chat, which can take multiple iterations, as I think you guys have all seen just in conversing with ChatGPT. Sometimes this actually does involve, I found problems with the code. I want you to fix something, your shell script didn't run, rewrite it. All of those things can happen in this process. But again, that happens when we're writing code in general anyway, right? We have various iterations where the thing that we wrote didn't actually run. And so we have the agents now, sort of discussing this task. And in this case, I've got the web compiled successfully. Let's do a reload real quick. And so in this case, live demo, folks, I didn't get the feature. So what I can do, though, is I can go look at the chat log, and I can see here, what it actually did. And I can go back and inspect, well, why didn't I get the feature that I wanted, right? If I run this again, am I going to be able to fix my problem? And so in all of these cases, right, I'm getting live feedback on, does the application actually work, right? Did I get the feature that I wanted? I'm able to see the code on disk. And then if I want, I can also go and I can rewind, right? I can just say, you know what? I don't really like any of these changes. I'm going to go and just overwrite this repo. And you can see here, now I'm back to where I started. So I created an iteration, right, that, fundamentally was agent generated, right? I got some of the features that I wanted. I didn't get others. I could have committed those things. I could have added the files that changed, or I can rewind to my breakpoint, and try again. This is very similar to what we do, in software development, right? And really the difference is I'm not writing the code. I'm merely giving the instructions and providing kind of a shell around the process. So I want to jump back into slideshow land. What does this mean, right? What this means is that, you're seeing this process, again, in a fully automated AI context that is very similar to what you get, when you're working with a dev team. You introduce the code base. You break down the tasks, right? You create a script, to make whatever changes you want, or, in real time, edit the code, right? If you have errors, you fix the errors, right? And when you're done, you end up in a place that's fundamentally either, pushable or not, right? Maybe I make a PR with this change, maybe I don't, right? And that's another thing that we can do in an automated fashion with the agents. And so, because we've replicated some of that process, we think it is human readable and inspectable. We think that's important for right now. And, you saw the speed there, right? The idea that I can make these changes in seconds, right? Even for simple things, 1-point stories, very simple changes. This typically takes, hours to days in the world of code. And so we've also got a number of concepts around more advanced agents for larger tasks, right? And the task I just showed you was very simple. If you want to actually plan out, here's exactly what I want these changes to be, right? This adds to the inspectability. It gives more context, to the agents to do a better job. As you can see, I didn't really tell it, how I wanted things styled. It just inherited styles. I could change that here, right? All of these agents are going to be able to add context the same way that you would in having a more advanced dev team. So the planner is one example here, an engineering lead who's going to actually give feedback, right, to the plan, right? Here's what we should actually do. Here's things you need to make sure that you do with every step of the plan. So fundamentally, we think this is really just a matter of not if this can be done, but exactly how. And so the model that we're coming to is an agent-driven development model where product and engineering are really paired together, as opposed to what you saw earlier when Michael was talking about the concept of the traditional model. The traditional model would have engineers either paired or working on technical tasks, product and design as input. This puts all the humans together working with agents to get changes that you can review in a very, very short period of time. It completely changes the way that we cycle on software. So again, just to recap what we saw that agents and teams of agents can create working software from non-technical requirements. I didn't tell it how to do things. I just asked for it to be done, right? We can see that agents can decompose larger things into smaller steps. We have proof that that works better, right? The smaller the steps, the smaller the iterations, typically the better those things work. They can critique each other. They can improve their own systems. They can produce this inspectable chain of thought, and they're fast, right? We are not saying, although we'll get to sort of our predictions, that this solves every single software problem. But you can clearly imagine, and we hope that you guys are doing this now, you can imagine software problems it probably does solve. Can this take care of your bug triage? Can this take care of very simple stories? Can this take care of more complex stories with guidance, right? Can you get to the point where humans are really reviewing PRs, more so than they're creating the code, right? I think all of that is very achievable. And briefly, just to speak to the roadmap, this is, again, stuff that we hope to speak to you about in future webinars, as well as, in other forums. For any clients, we're happy to have deeper conversations with you at any time about this. We are clearly at the point where we can make enhancements to small code bases. We want to add additional architecture and context, to enable changes to larger ones. We think as you get to extra large tasks, there's going to be, again, more sort of these agent configurations that'll help with those larger things. And ultimately, we want to really integrate the design process, right? We think one of the big things that we have not cracked yet is exactly how design and product really fit in with this. How much do you need to give, context to these things? How do designers interact maybe with some of these changes that have already been made and help fine tune them? Those are all great questions. And likewise, with use cases, we've spent most of our time so far on the brownfield problem, right? You have code, right? Because most of us, I think most of you included, have code you want to work with. For greenfield, I think we can imagine, sort of how that works. But then separately, going from designs to code, right? Modernizing code bases, replatforming. Those are all things that we genuinely do believe are possible with the right process. Okay, so I want to jump into predictions here and hand it back to Michael.
Awesome. So as we start to think about where this goes, we stumbled upon or sort of remembered from the back reaches of my mind, this is an autonomy story. My previous employer, we were building autonomous factories, right? And that meant basically taking tasks that humans do and sort of going through this level of autonomy and increasing levels of autonomy, creating a system that gets more and more autonomous. And I think it's a really important way to think about where this goes, and I think it'll make that nice and clear. So level 0 autonomy is no autonomy, right? This is our traditional software development lifecycle. With level 1, that's sort of where you are with Copilot. So if you were in a factory, you replace what a person does with a machine, but the person is fully operating the machine. That's very much like how Copilot works, right? I'm going to write this function. Now, they've got the magic of generative AI and LLMs in that you're able to do something that's non-specified up front, which is super exciting and interesting, but still the same sort of general idea. When you get to level 2 autonomy, you start integrating and connecting those different locuses, right? So this step and this step are now working together. This step and an automation that checks for quality, right, is happening. So like you get these different pieces that are kind of connected to each other in order to perform larger tasks, but they're still kind of human instigated, right? The process is still being kicked off by the person, measured by the person, looked at by the person. And that's really where the demonstration that we just saw is, and that's probably where we're going to play for quite a while. Level 3 autonomy is sort of a regulated autonomy, right? And this is more like sort of a gatekeeper kind of function. you could easily see, I think, as Dan was alluding to there, you could have bugs that pop up, or error logs that get brought up, automatically turned into stories, automatically turned into PRs that might solve that problem, that can then be reviewed by someone further downstream. So you could see this sort of like system where things are really working, but you still have that governor, the person's able to regulate what's going on. After that, you get into something that's a little bit more complex. You get self-healing and self-advancing systems. You could think of a system that's coming up with ideas. We have one customer who we're working with who they have a whole bunch of Zendesk tickets that come in from their customers. We're helping them to leverage generative AI to get insights out of those Zendesk tickets, and also to sort of take these different disparate elements with the context of their business, trying to take and map those different challenges or issue tickets that are coming into their system, into customer support, to group them together and to come up with hypothetical solutions. You could see tying that together with CodeGen, where you've got a whole bunch of Zendesk tickets coming in, they're getting triaged into, here's a particular issue that's being converted into a user story, which is automatically being developed and deployed. Now, whether that's regulated or not regulated is sort of the difference between level 3 and level 4. But this sort of framework is what we use as we're starting to think about where this is going and where some of the predictions that we're about to make come in next.
Great, thank you, Michael. So to speak to a couple of specific things, and we are a little out of our skis here, but I think in an inevitable way, we think one-point stories are going to become a thing of the past, right? And this is specifically because you can see that when the changes can be fairly localized, when the code is readable, right? These are all not givens, but they're things that I think we can work towards. You'll fundamentally see, a number of different parts of, the current essentially team time and sort of, the commitments teams make to themselves in the middle of sprints, right? A lot of that work is going to be able to be transferred to autonomous agent teams, right? Now, some of this, to speak to what Michael said about autonomy, right? There still needs to be, at this stage, I think, reviews. There need to be, essentially, there needs to be a way to fit these changes into the overall framework. You can't just fix every single bug or take every single customer request, pump out a bunch of code, merge it, and expect things to work, right? That is a recipe for disaster and spaghetti. But we think if you can process around that, the actual effort required in writing the code and getting something to review is going to be vastly reduced, right? And then we do believe that you can go from there into increasingly larger tasks. So again, to the point of levels of autonomy, we think that middle level is a great place to be for now, right? Because it does still give humans and human processes a fair amount of oversight and control. But we do think there'll come a time when, humans will again be the bottleneck. It'll just be different humans. It's not going to be the humans who write code. It's going to be the humans who approve code or push code or make changes to the business. So that's one. We also very much believe that you're going to get to the point where right now we make a lot of trade-offs in the code that we write for readability. We expect humans to have to maintain the code that we write. That is a fair expectation. But as a consequence, our code isn't necessarily the most performant. Our code isn't necessarily the easiest for machines to write. We will get to a point where we trust a lot of these processes to the point where for certain parts of your code, you're not going to care if a human's going to read it because they're never going to touch it, right? And we believe that there's going to be, a new set of operating procedures that basically arise within teams to make certain code, still very readable and accessible, and other code, you're not going to see. This is obviously what has already happened in large part with close to the metal machine code, and things that compilers only have to read. To that point, we think that around the code, you're going to have a much more robust shell. And what we mean by that is assume for the moment that if the code passes the tests and is performant enough, it doesn't really matter necessarily how it's written and what it does, but you have to be able to run a number of verifications on it. You want to be able to run tests that either you or AI or both have defined. You want to be able to do basic security audits, penetration testing, all the stuff that you would normally do on applications, I think becomes even more important. That shell is going to be the thing that really gives you confidence in what code you have and what it does. And a last point, and Michael, I'd love for you to jump in here too. Agility is going to really be more important than historically agile process, right? We are an agile XP shop. We talk about this and think about this all the time. we genuinely believe that this is going to change the nature of how you iterate, right? And the size of your increments, the way that you change, software, and the way that you take in business requirements, all of that stuff, because of the nature of these cycle changes, is going to need to change, right? And we want to help, over these next few months to try to define what we think that process really should be.
Yeah, and new bottlenecks too, right?
Yeah.
You can imagine if you're in an organization that's going through growth and you are constantly doing these sort of 1 and 2 point stories where you're updating your funnel in order to try to increase the performance of your business, you can run a whole bunch of different tests at a given point in time. But in this initial phase where we are all inspecting and making sure that this system is something that we trust, or that it's meeting particular standards, or needs to be configured in different ways, you might generate a ton of PRs. And now your bottleneck might be PRs. Once you get through the bottleneck of PRs, it's the speed of ideas, right? How quickly are we able to, as an organization, align on what the next most important thing to test is? Those cycles of sensing and responding are going to be so fast. How do we ensure alignment across different groups? Do we need to organize differently? And thinking through and solving those problems is something that we're super interested in helping solve, because it's really going to change the way that we do business.
All right, thank you. So one final thought, and I was just clued onto this yesterday by someone on our team, Ben. Hat tip to Ben. A great lecture by Matt Welsh, who's probably most famous in the world as being Mark Zuckerberg's computer science professor at Harvard. But he did a long talk, with with very similar themes to what we just showed you, with a bit less code. And really, I think one of the conclusions that he came to is, fundamentally, the discipline of computer science is changing, right? It already is becoming, I think, more specialized because of how much easier it is with LLMs to write the code. And so most people who build software aren't going to be doing the programming. They'll be interacting with an AI that does. We think this is ultimately a good thing and qualified, right? We don't think this is true, especially of some of the more complicated software that's out there. We think you're still going to want a lot of humans driving, a lot of these processes. But there are clearly parts of it that the AI is going to be as good at or better. And it really does expand access to, anyone who is good at expressing themselves to the AI. It's not going to be something that is completely localized to people with computer science degrees or people who have, direct programming experience. So it's a very, very, it's a nascent change, but it's a real change, and we've already started to see it.
Yeah, and as one of our friends has mentioned, is English is the new Python, right? Being able to generate Python is really just at the grasp of being able to describe what it is you're trying to do.
Yeah. All right, and let me hand it back to Michael and Debbie for our offer.
Yeah, thanks so much, Dan. So really, for this just last piece is a little bit less about CodeGen. If you are, wherever you are on your GenAI journey, whether you're doing a ton of stuff with GenAI or you're just getting started, we have ways to engage with you, to help you, to build a POC, to prototype, or to build out a production version of your LLM. We can help you with your use cases. We can help you with your deployment, and all that kind of stuff. It's something we've been doing a ton of in the past 6 months. We've allocated a number of hour-long slots over the next 6 weeks. If you're interested, we'll give you some information about what's going on in the world of GenAI. We can chat about your specific situation and just give you some feedback on what you're doing. Some tricks and tips that we've found as we get into this space. We're inherently a bunch of teaching-oriented folks. We love sharing information. We love chatting about these things. And please do get in touch. That'll be part of the follow-up email. And now the best part, Q&A. We're gonna, before we dive specifically into the questions and answers, we're going to be posting videos on versions of what we find, some of which are already well beyond what we saw in the demonstration today. And just to, keep up to date there, give us a follow on LinkedIn. More and more fun stuff to come. All right, questions.
Yeah, awesome. Oh my God, guys, that was amazing. Thank you so much. I love that. Like I knew what you were creating, and as I was listening to you, I continued to just really just enjoy hearing you share your updates. So thank you so much. And as I'm reading off the first two questions that we have, please do feel free to ask additional questions. And as Michael said, we're going to be sending you an email so you can ask more questions there as well. But for any that are burning on your mind, we'd love to dive in. So, guys, the first one's from Jason, and Jason wants to know, how would you compare the experience of reviewing code generated this way versus from a human written PR?
Ooh, can I take this one, Dan?
Yeah, go for it.
So our goal is for it to be the exact same thing. So we are working on versions of this where the code that gets generated just automatically creates a PR. So you saw today the sort of the Python script and leveraging AutoGen in order to update the features. One successfully, one unsuccessfully. Live demo. But we have systems that have many more toll gates in there, and part of the end state of that is for at the end of the process, it just generates the PR. You get to see your diffs as you would any typical PR. It should fit right into your system. So whether that story is something that's getting kicked over to a team of agents to deliver, or whether or not your team is doing it, they would still have that same flow of getting notified that something is ready for PR. They've got their Slack message, they've got their alerts, they've got whatever it is they typically do. They can do that review and make the comments, and ultimately just be able, if there's changes requested, right there from the PR, be able to send it back into the agents to get fixed and updated.
Yeah, and just to add to that, I mean, I think the feedback we've gotten in talking to some folks pretty early about this is that feels ideal, right? It feels like, well, that just gives me a bigger team, and I'm not really changing a ton about how I'm processing this, right? I'm just providing more capacity on this thing that right now is capacity constrained. Now we do think that over time that flips, and we don't know what the proportion is, but we think that over time you're going to get good enough at pushing the code that you're just going to be overwhelmed somewhere upstream, right? And it's going to be either the number of ideas you have and the way that you process them. Do you build multiple features in parallel and pick one, because you only, think you should make one change at a time, but, it's cheap enough to make all three, why don't I make all of them and either test them or whatever? This gets very much into sort of growth and optimization mode, which is usually somebody else's job, right? So on the one hand, you really do want the PRs, to be things you could just take and run with. You may just have a lot more of them, and you may choose to ditch a whole bunch of that work. Because it's so cheap to make it, we think that's okay. That's the major change we would see.
Awesome. All right. So we've got a bunch more rolling in. So John, I'm smiling because John's question, I was actually wondering this myself, and it's, I'm part of Stride. So are the autonomy definition levels that we shared, did we create those or are these common industry levels?
So these are paraphrased down from work I've done with building autonomous factories, which itself had sort of taken the ideas and pared them down from autonomous vehicles. So this is sort of a pulling together of different methodologies and trying to explain where we're going within a framework that's similar to the way that vehicles, manufacturing, these other places are also thinking about it.
I mean, this makes sense because like Agile pulled from the Toyota
exactly
way,
the Toyota
right?
production
So
system. Yeah.
This is just going back to the beginning.
Yeah, I
I
had that
love it.
same thought this morning. I was like, oh, right, because we took everything from automotive and how we build stuff. Anyways, I think one really important thing to build in here is when you're building a factory or a car, there's sort of a done, right? You go through these levels of automation, and you get to this place where you're in your car, you put in the button, and it takes you exactly to where you want to go. I you know I don't think we would ever trust the taste of a generative AI to say this is the right feature for my company, or this is the right thing to build. So I think like the right place for us to sit as technologists and people who build product is going to be in that sort of level 3 zone primarily. sort of like level 2, level 3, having recommendations made for us. You can imagine, you get, you create a new story, or you get a new bug that comes in, and the solution is automatically created and put into a Docker container where you can go view it and see if it's a thing, and you can accept it or reject it. It just flips the way that we approach this on its head.
Yeah.
Great.
And just a quick note,
ahead,
on that. Taste. I really do want to emphasize that point, right? If the job is not creation but curation, right, then taste becomes extremely important. I think we have to be careful about saying, we will never trust a machine's taste. We probably will, and it's just a question of like, can I afford to, right? Am I a solo person running my business and writing a bunch of code, and I get to the point where I trust what the agents are building me, and I'm just cool. Yeah, like let's try that. Right. There's all sorts of different, levels that I think we're going to see people building, at. And I think where you have the apparatus, of people and sort of, business process, we should be spending a lot of it on taste. Is this good for the product? Do people, is this really what the customers want? And is it done our way? Right. We all know that there's businesses that have been, built almost entirely on taste, right? They're equivalent products. People just like them better, and, and they're sort of packaged better. That is very much a thing we're going to see more of.
Okay, great. So we have a few more, so I'm gonna keep us going. So Irina asks, gosh, I love these questions because I have all of the same ones. So thank you guys for these amazing questions. So Irina asks, as an engineering leader and a mother of a computer science student, wondering how this impacts our ability to grow the next gen of software engineers, because typically you start, these newer folks on the 1-point stories, but if those are going away, where does that leave our ability to grow the next generation?
Yeah, I'll take the first run at this. As a parent of a 14-year-old in a pre-engineering academy, I very much empathize with the question. I really what I think is going to happen is that there will be other ways to apprentice, right? That I agree that the current pipeline for computer scientists is you either do research, right? And the research is something that you can be guided by, sort of more senior people, above you, but, with your ideas, or, it's the sort of small, easy, but, kind of indicative tasks that get you into the flow, right? So that you know how to do things. I think there will be an equivalent of that with, things like this, where you're orchestrating changes to an application, you're just not doing it in code. I think it is also appropriate to think about like, hey, if I took an electrical engineering class, I probably understand how a circuit works. And that's helpful to me in my job, but I'm also not an electrical engineer. I think there will be a lot more people who are, savvy enough about computer science and about LLMs that they understand the basics, but fundamentally it's not their job. It's not what they do all day. Right. And so I would not at this point suggest, and I'm saying this to my daughter, I would not suggest, go into computer science and plan to be a coder for the rest of your life. I don't think that job is going to be what it has been. But I think there are hybrid jobs that still depend on those kinds of skills and still depend on, a certain place in these workflows. And again, the workflows are going to change, right? So like, whatever we tell our kids to do based on the existing, kind of agile industrial complex is probably not appropriate, but there will be something new that emerges, right? We want to help find what that is.
Yeah, and just the one other word literally that I would add into this is more of a apprenticeship model is potentially where this goes, right? Where you pair someone who is further along in their career and who can manipulate and evolve these systems, and they're paired with a younger person who is learning the ropes. As opposed to the person being sort of put off on themselves to go deliver 1-point stories, they're soaking in the sort of larger decisions, architectural considerations, working with other teams, problem solving, all that kind of stuff.
Yeah. And the high level answer is nobody really knows. And this has happened before, right? Like that, those are the two, right? Like we don't really know. And this has happened before in other disciplines, right? Some in recent history, some in more historical history, but there are things that you can do to, move these things forward and be part of the solution, right? Because there is a lot of opportunity to integrate junior, because we always need the next generation of employees in all disciplines. So this is going to be an interesting one to keep an eye on. So we do have 3 more questions. I want to make sure we have time to get to them. And folks, keep them coming. These are really great. And again, we can always answer more offline. Stuart asks, can you speak to privacy concerns using generative AI with a proprietary code base, for example?
I think there are a couple of ways to think about it. So one is that in our experience, we have found very few clients and customers that we've talked to who are unwilling to use Copilot, right? So that's one bar. They do exist, right? There are people who say, nope, this can't touch anything inside my systems. But I think there's both a level of trust with OpenAI and Microsoft. There's a notion of I can have private GitHub repositories, and I consider that to be, sort of sufficient security. So there's definitely, I think, a lower bar given, who's doing a lot of this, right? Like trusting OpenAI and Microsoft doesn't seem super crazy, at least sort of within the confines of these tools. Some people wouldn't put the same code into ChatGPT, right? So, same people, but different, shell. So on the one hand, like, I think there is a level of trust growing where people are not fundamentally as worried about this. But it is entirely possible to spin up completely private versions of this exact same infrastructure. We choose to use OpenAI at the moment because GPT-4 is objectively the best at this, right? It is the best coder. It's the best reasoner. We do believe there are other options that are not much worse, but at this point, we think that using the best of breed for something that is not being done at massive scale, right? If you had 30 million users, you're going to look very hard at cheaper models. When you are writing code for yourself, and especially when you're already spending the money on writing code that you are, cost is simply not a consideration. So like hybrid of, we think that it's kind of the security questions are partially answered by the players involved, and most companies have gotten comfortable, and there are options if you don't want to go that route.
Awesome, thanks. All right, so we've got two more. We've got about a little over 10 minutes left, and I think we'll be able to wrap up in a little bit under that. So want to get to the next two questions. So Rick asks, how do you envision these programs keeping in mind the history of coding and architecture decisions the team has made? For example, as we continuously improve how we write code and how we structure our architecture, he'd like the LLMs to maintain a memory so that it applies it. When engineers write that, excuse me, into the prompt, or would there be a database of decisions somewhere?
Yeah, so I think there's a couple things that could happen here, right? And the one that we are ourselves working on more actively is this notion of a repository map, right? So if you assume for the moment that the major problems you're going to have in writing code like this are, I'm in a given repo and I need to know all the code in that repo, so that the code that I write fits and interfaces correctly with anything else, kind of in a live fashion. That doesn't necessarily speak to APIs. It doesn't necessarily speak to broader architecture of your company or your entire product. So, but we're starting with the idea of, we think the repo map is enough for most things, right? Beyond that, then it's kind of a question of, well, if these were humans, you would have, a Confluence page or a series of them. You would have documentation at a high level that helps people map things out. We really are treating this, apparatus the same as we would a team of humans. They don't need to know absolutely everything. If you do just dump the entirety of human knowledge into them, they either can get confused or they don't sort of know what to pay attention to. We do think that there is a reason to be more limited than that, but some combination of a repository map and then, actual live documentation. If you tell the thing in plain English, this is how my application is set up, it gets it. We've done that, right? We've said, I'm about to dump a whole bunch of code on you, and here's where it sits in the context of my product. And it actually gives very reasonable answers and is a very helpful pair, right? We haven't used the agent approach on that just quite yet. I hope that answers the question. It is very much a concern, but we think it is a matter, of kind of giving the same level of granularity of documentation that you would to a human team.
Mm-hmm, mm-hmm. Yeah.
And there's something else that's interesting in here too, is this sort of, especially if you imagine this is a hybrid solution, right? Whatever code is generated will have a faster cycle time, right? It'll have higher throughput over a shorter period of time. But there are problems, which I think will be decreasingly fewer or increasingly fewer, that we as technologists, as teams, are solving as humans. And so when a coding agent group makes a change, it can't negatively impact the cycle time of that team, right? If our coding standards are we put functions at the top, or we put functions at the bottom, or we use this particular pattern or that particular pattern, that's something that needs to be maintained, and something that we've been experimenting with. We had a spike the other day where we returned something back, and instead of const, it was the, right? And so all the tests failed, and the debugger sort of went off and said we need to make some fixes. You can imagine a version of a debugger that is sort of a staff engineer type, which talks about the standards and the philosophy and the different approaches that people take when they're interacting with your code base. You could think of just like the debugger would review and make sure that there's no issue before pushing a change out, that similarly, that agent is also making comments on whatever is coded by the team of agents, and ensuring that they're meeting those thresholds of quality that your team expects. And that's been promising so far. We've run some experiments in it, and we'd be excited to share more in the future.
Thank you very much. All right, so one more came in, so I'm going to get to both of these. So just keep an eye on the time, but we're doing great. So we got plenty of time left. So Brian asks, I'm going to read it. Benchmarks for the best LLMs like GPT-4 are still putting themselves in the roughly 5th percentile of human programming skills on tests like LeetCode and Codeforces. Meanwhile, they're super good at verbal and communication skills in English, like 80 to 99th percentile. Wow, I didn't know that. It seems like this is why we only see agents working on toy problems and toy apps, not real apps with millions of lines of code. Why not flip the levels of autonomy and start with tasks that current LLMs are good at, like generating user stories based on the inflow of bug reports and client requests? So you guys can read that question because there was a lot to unpack there, but
yeah, it's an awesome question. And at the same time, it actually gives me a chance to jump on a soapbox on a couple things. So I apologize if this comes off at all snarky. Hopefully it doesn't. So on the one hand, right, I think the question of like what the LLMs are currently good at, right, to some degree, yes, they're good at generating English, but they also have this issue of hallucinations, right? What if, you get something that is, it sounds plausible to a human, but it isn't actually the thing that you wanted. And the other part of it is that's not really where the bottleneck is, right? English right now is an input to this coding apparatus, which is bottlenecked by the number of programmers you have, right? So to some degree, I think it's just that's where the business actually, the business outcomes can be radically improved by figuring out ways around some of the coding bottlenecks. But it's also a lot easier, I think, to build this shell around code where you can verify that it's doing what it's supposed to be doing, and that fundamentally it provides the same outcome that originally you wanted to get from your software. And so, but at the same time, I take the point that no, it's probably not going to beat a human programmer just yet at LeetCode style stuff. That's also not what most programmers spend their time doing, right? So the main thing that and I think there was an article we posted a few weeks back, basically calling AI a loom. Now the point of a loom is not that it is able to produce any arbitrary intricate pattern. It's that once you have a pattern, it's great at reproducing it. And we think that that's really what LLMs are great at, is that if you give them a pattern to observe, and Michael mentioned some ideas of agent configurations where you try to enforce things like coding standards, you try to make the patterns that much tighter and better. That all feels very, very worthwhile. But the amount of actually novel code most people write is minimal, right? The systems get larger, right? So we need to be able to deal with that. But like, hey, there still will be computer scientists who are doing novel, interesting work that may beat LLMs for years. We 100% subscribe to that. We just don't think that's most of what people do with their programming.
Well, and that's also, I think, why the approach that we're taking and what we think is the way to do this is to start with the simplest problems. Right, those tried and true things that are resolved over and over again. We're gonna add a new attribute to a form, right? Happens all the time. We're gonna update the language on this landing page, or we're gonna reconfigure the components on this landing page in order to see if we increase conversion. Those are simple problems, and we can ensure by putting teams together that those are solvable problems. And I think those really big hard problems are yeah, like those are the things, that's your 13-point story, that's your 26 or whatever the next 21-point story. whatever the sort of larger order of magnitude researchy type challenges, right? You confine it to the simplest thing until you ensure you've got the right configuration. It does it over and over again, and then you kind of go up from there. And that's the approach that's taken for automating factories, right? If you're automating putting a t-shirt together, you don't start off by figuring out how do you attach the collars. You start to figure out by how do you attach the front and the back, and that gets you to sufficient gain, and you're able to increase throughput and focus all of your resources on putting on collars with people in a more and more automated fashion. So you just sort of you do start simple.
Yeah.
And also, I think the other answer is why not both, right? I don't think it's an either or focus on one or the other. I think
that's a great point. Yeah, absolutely. So we have one more question, and if we can take about 1 minute to answer it, that would be great. So how far out do you think these tools are for mass adoption? Like we've been talking about, it's not a black and white answer, but if you can give some brief thoughts, that would be great.
Sure. I'll go real quick and really just to say, I believe that this is not about if these things can be done, if increasingly large code base changes can be made by LLMs. It's how. It's just that we have not discovered the particular method, right? And so we think that in the short term, there's a fair amount of customization that's going to be required to get into an environment and a code base and come up with the appropriate configuration of agents, the appropriate way to put requirements in and get code out, the appropriate way to review that code. We think all those things are bespoke for now, right? We don't see people ripping off the shelf tools that do all of this. And that's one reason Copilot is what it is. Copilot is very much not asking you to change your workflows. It is simply trying to incrementally speed up your developer operators. So I think it's just a matter of finding enough of that, process to where you can get comfortable with, some piece of your dev team's work being done this way. I don't think that's a high bar. I think that's really just a matter of finding, people who are committed to being a little bit more efficient with their resources and are interested in trying this out. We genuinely believe that it's ready to start doing some of that.
Subscribe.
Excellent. Yeah. Carlson, do you want to jump in or go ahead?
Yeah, no, I agree with Dan. Just wanted to +1 on that.
+1. All right. And with that, oh my gosh, I love it. I love Zoom, all the new things. Guys, this has been a wonderful hour, completely educational and fun. And so thank you so much for staying with us, for joining us. We will send you this via email in the coming days. We're here to help, and have a great rest of your week, everybody. Take care.